The Perma-Proto board ATmega project involved taking the breadboarded circuit and soldering it onto a Perma-Proto board. Here, the soldered addition includes an extra power jack, an on-off switch, and a mountable reset button. Resistors and capacitors are able to be replaced, and the square wave from the 555 timer can be used externally. Code can also be successfully flashed to the ATmega by attaching the AVR breakout board and Pocket programmer to the 1x6 female header. In this example, I reflashed the code to remove the dots after the words waiting. Parts for the project remain the same as the breadboard prototype, with some extra components added on. The basis of the project comes from the 30-column Perma-Proto board, manufactured like a standard breadboard for easily transferring components. The challenge, though, was to fit the contents from the full-size breadboard onto a space half its size, requiring thorough planning and organization. I had already done some of this beforehand by limiting my space on the breadboard prototype, which allowed me to transfer my circuit easily without rewiring major sections. Though there were some necessary changes I had to make, the main one being a more friendly way to upload code. So I devised a rough plan of my circuit on the board and marked spots for components and where I needed to cut the copper tracings. This useful feature of cutting allows for full utilization of space and more flexibility with components, as columns can be separated from connectivity, allowing me to route the respective connections to a 1x6 female header, which attaches to the AVR breakout board like so. Another feature is the ability of wires to be routed on either the top or bottom, providing better organization and less clutter. With these handy tips and that rough sketch in mind, I began soldering in sections, making sure to check the continuity of components and to frequently test the whole circuit. I also implemented a few tips I learned from soldering my grade 10 ISP project, the analog traffic light, such as soldering the joints on both sides of the board for better continuity and cutting my own wire to better fit the circuit. The first section I soldered on was the 555 timer, where I used these breakable female headers for the RC pairs and 1x2 female headers for outputting the square wave and power lines. Next, I did the ATmega328P section, adding an extra 1 megaohm resistor across the crystal for a more reliable oscillation. Moving on, I placed a 1x4 female header to insert the OLED display and replace it if need be. I also moved the output LED from the 555 timer square wave directly below to save space. The final part I soldered on was a 5-volt regulator and the mountable components. Here I added extra capacitors across the power lines for smoothing out power spikes. And with all that soldering, planning, and testing done, the rough expectation became a reality with the project fully functioning. Overall, this journey fully tested my planning, attention to detail, and patience by transforming a prototype into a permanent working build.